Standard form of a linear equation. We've already gone through just a few of them. We've gone through point slope, and we've also covered, whether you like it or not, slope intercept, which is usually the best one. But I'll show you how standard form can be used very, very well. First thing we have to realize is what is standard form. So we have ax plus by equals c, where a, b, and c are, well, a and b are coefficients and c is a constant. Remember, coefficient is the number in front of. So an example would be something like 5x minus 3y equals 10. So this would be an equation in standard form. Notice I can use plus or minus. We're just saying the coefficient of b here is negative 3. So we do have a couple rules that we want to keep in mind. I want rule number 1, x and y on one side. So on one side. And number 2, I want a, b, and c to be integers. Okay. Remember, integers, we're talking about positive or negative, but no decimals, no fractions. Alright, while we're talking about a, b, and c being integers, notice I added 0.5. Remember, we can't have any decimals either. What we do have to talk about is a, b, and c cannot have, so, or the only GCF, so a, b, and c GCF should only be 1. Okay, a, b, and c GCF is equal to 1 only. So if I used 5, 10, and 15, well, 5, 10, and 15 are all divisible by 5, so that would not be in standard form. And then the last one, notice I added this plus sign up here. And this changes somewhat by author, but a, the coefficient on x, must be positive. Okay, and that'll change, like I said, by book, but that's the way that we're going to run it. Now, this is where it's going to help, is we can deal with x and y intercepts. So what we have to notice is that if I have the x-intercept right here, well, what's the y value, right? Here's my y-axis. That's going to be 0. So it's going to give me x and 0 for an x-intercept. And the same thing the other way. So what's my x value is 0 and y. Now, when we talked about y-intercept before, we said that was b. So if I see this, then I realize already I have b if we're going to deal with slope-intercept form. But today we're going to deal with standard form. Alright, a couple things we want to do then is we want to graph both of these. Notice one of them is in slope-intercept form and one of them is in standard form. So we'll see how that works. So if I take slope-intercept form, so here's my y-intercept is 4, 1, 2, 3, 4. And my slope is equal to 2. Well, that's 2 over 1, so 1, 2. And over 1, rise 2, run 1. And we can connect those two. So that's what we have. Second line, if I want to use intercepts, remember, we're using this idea that the other one has to be 0. So if I want an x-intercept, I'm making y 0. So let's do that first. I want the x-intercept, so I'm making y 0. So I have negative 2x equals 4. So I have x equals, divided by negative 2, divided by negative 2, negative 2. X is negative 2. Alright, now we'll start that all over again. And if I want the y-intercept, I'm making x 0. So if x is 0, 0 times negative 2 is 0. 0 plus y is 4. Or 0 plus y is y, and y equals 4. So y equals 4 is the other one. So y equals 4, 1, 2, 3, 4. Would you believe you get exactly the same thing? So if I was going to take this and extend it down and be nice and careful with it, I would see it's going to go through 2. I'm missing my points just a little bit. Alright, there we see it's going to go right through 2. Same thing, equations both ways. So just trying to show that they are the same thing. And for certain equations, it's going to be easier if it's in standard form just to go ahead and find intercepts. Another thing we have to take care of is vertical and horizontal lines. So if I have single x and y intercepts, so if I have x is equal to 2, well, what I have to remember is that when I have an x is equal to 2, it means it's going to go through the x-axis. So what I want to do is go through and label both of these as the x-axis and the y-axis so I can find all of these. And if I have an x equals where it's going to go through there, I might just turn this up on its side, because that's what I'm looking for. Where x is 2, well, that's this line right here. Y is equal to negative 7. Y is only negative 7. Well, that looks to be this one right here. Y is negative 1. Y is only negative 1 right here. Y is only 4. Notice it's going through the y-axis at 4. So that's my easy way to identify these. And x is, so I'm going to turn that one up. X is negative 5. X equals negative 5. Do we have one more? No? Well, what would this one be? Be an x equals or a y equals? First I see it goes through x, so it is going to be x equals, and we'll have to count it out. 1, 2, 3, 4, 5, 6, 7. X equals 7. So x is only 7. And we'll just leave it right on top of there. So for vertical and horizontal lines, that's how we'll take care of those. They also have the y-intercept or x-intercept, but only one of them of exactly the same value. Okay, so finding x and y-intercepts, here's what we talked about, x and 0. So that means I'm going to take this guy and replace it with 0. Okay. So we can take the 2x and bring this whole thing. So 2x equals 6. That might be hard to see. Let's rewrite that. 2x equals 6. Because we're plugging in 0 for y, and 0 times 3 is 0, so I don't need that at all. So 2x equals 6, divide by 2. X equals 3, so we're talking about 3, 0. And if we start that whole process all over again, if I'm with the y-intercept, I'm making x 0. So I'm plugging 0 in here. 2 times 0 is 0, so I'm really just dealing with 3y equals 6. So hopefully with this problem you see how this could be a little bit easier to use intercepts instead of changing it to slope-intercept form. I put in 0 for x and I got y is 2, y is 2. That's the other nice thing. I know I'm talking about a y-intercept because it says y equals 2. I know I'm talking about an x-intercept because it says x equals 3. Okay, so not so bad. It's pretty intuitive that way. Let's try that again. Let's grab an equation. Let's call it 3x plus 5y equals negative 15. So the first thing we're going to do is pretend that one of these isn't here. So I'm going to start with 3x. So 3x equals negative 15 because we're saying that y is 0. So this part has gone away. And I'll redo it the other way. So I'm saying that x is 0. So I'm going to get rid of this guy. So 3x is gone. So 5y equals negative 15. Divide by 3, divide by 3. X equals negative 5. So that's the negative 5, and it is the x value. And the other one, if we're talking about an intercept, must be 0. Divide by 5, divide by 5. Y equals negative 3. So y is negative 3 in my ordered pair, and we're talking about intercepts, so they will must be 0. If I want an x-intercept, I'm making y 0. So I'm saying y is 0, so x is 18. For the second equation, I'm doing 2y equals 18 because I said x is 0. So y equals 9. So I have 18, 0, and I have 0, 9. So pretty good practice. Solve for x and then the y-intercept. So x-intercept means I'm going to make y 0. So I'm taking my equation 3x equals 9. I made y 0, so I just get to get rid of it that way. Divide by 3, divide by 3, x equals 3. 3, 0, x is 3, so x in my ordered pair is 3. Now we have negative y equals 9, because I'm taking 3 times 0 minus y equals 9. Well, that's just 0, and I'm not going to write that again. I'll treat this as negative 1, so we're going to divide by that negative 1. So y equals negative 9. So I have 0 and negative 9. Alright, so 4x equals negative 12, and we'll do y equals negative 12. Well, this one's done, so let's go ahead and get our ordered pair. Again, I'm making x 0 here. X is 0. Over here I made y 0. So when I get done, I'm going to have something and then 0. Divide by 4, divide by 4. X equals negative 3. Not too bad, not too bad. Let's try one more of these. So again, I'm going to take x-intercept first. So x equals negative 72. Well, how about that? That one's done. And then we're going to take over here, we're going to do negative 6y equals negative 72. Divide by negative 6. Divide by negative 6. So y equals 12. So y equals 12. So we have 0, 12. Alright, next thing we want to do is graph. So if I want to graph this, and eventually what we'll do is we'll give you a choice. You can turn it into slope-intercept form, or you want to use intercepts. But right now let's use our intercepts because that's what we're focused on acquiring some better knowledge with, or better practice with. So here's what I have to do. X is negative 5. 1, 2, 3, 4, 5. Alright, now let's take, I want to get rid of the other one because I'm saying that's 0 now. So y is negative 5. 1, 2, 3, 4, 5. And connect the two. I have graphed it using my intercepts. How do you like that? Pretty easy, right? Alright, so the only thing we really have to do is be careful with our signs. So if first thing we want to do is x is negative 7. Okay, next thing we want to do is treat it this way. So if x is 0, then that's gone. So negative 1, y equals negative 7 divided by negative 1. So y is 7. So we're going to find where y is 7. 10, 9, 8, 7. And then we can connect the two. Alright, we're trying to make it a little more challenging, throw some extra numbers in here. But it's still not going to be very difficult for you because you're smart enough to take care of it. So let's get rid of that first. Divide by negative 3, divide by negative 3. X equals negative 2. X is negative 2. Let's get a point on here. And if I go back and see what in the world I had before I scribbled it out, it was plain old y. Let's now get rid of it this way. So y equals 6. 1, 2, 3, 4, 5, 6. And then connect the two. Of course, we can extend our line back out the other way. That's fine. Just like that. So graphing using intercepts, not a problem, right? Last one for good measure. This might be a good time to go ahead and pause it and see if you can do it without me. Our x equals 3. Okay, divide by 5, divide by 5. X is 3, 1, 2, 3. There we go. Next thing I want to do, I'm going to grab my scribble and move it over. Get rid of this stuff here. Right, we divided by 5 there. So now I have negative 3y equals 15 divided by negative 3. So y equals negative 5. 1, 2, 3, 4, 5. So notice I'm going the y-axis, negative 5, and we'll connect the two. Alright, pretty good stuff. Now here's what we're actually after today. I'm trying to sell you on why we want to use standard form at all, but here's what we actually have to do. So right now notice it's in slope-intercept form, right? This would be m, this would be b, and we want to change it to standard form. So here we go. That means I want x and y on one side. Okay, minus 4x minus 4x. I have negative 4x plus y equals negative 7. I have a couple different rules. X and y on one side. Check, that one's done. A has to be positive. Alright, let's go ahead and get rid of that. So I'm going to multiply through by a negative. So as I multiply by through, all I'm going to do is change the sign. So 4x minus y equals 7. Okay, that's positive. Now out of A, B, and C, you have to make sure there's no greatest common factor other than 1. You have to make sure they're all integers. Right, so A equals 4, B equals -1, and C equals 7. We're in good shape. We have standard form. That's good. Alright, so we have it checked out. That works. Excellent. Alright, so again, they put it in slope-intercept form, but that's not a problem for us. We see the slope, we see the y-intercept is -3, but I want to subtract 1/2 x, subtract 1/2 x, so I have -1/2 x plus y equals -3. Now I have two issues right now. Remember, I can't have any fractions, and right now I have 1/2. So what I'm going to look to see is what exactly is the problem. And when I say that, I mean what's in the denominator. If I only have one fraction, then this is all I have to deal with. So in the denominator is 2, so I'm going to multiply by that 2. But I also have this negative, so I'm going to multiply by -2 so that the a term becomes positive when I multiply through. So I have a negative times a negative, which is positive. I have 1/2 of 2 is 1, so I have just plain 1x. Now we'll distribute the rest of the way. So 1 times -2 is -2y equals -2 times -3 is +6. Alright, so I know if I have 1 and 2, then I'm pretty set as far as greatest common factors. There won't be anything greater than 1. And we can pull our answer out here to check it. Nice. How do you like that? Alright, so we're given most of these in slope-intercept form because usually that's one method that we want you to change it from. So again, subtract the 2/3 x, subtract 2/3 x, so -2/3 x plus y equals 5, and again, we have a fraction in here, and my focus is going to be solely on the denominator. So what's in the denominator, that's what I multiply by, and I have to make it positive for the a term, so I'm going to multiply by -3 the whole way through. So negative times a negative is positive, that's what we want for the x term, and if I have 3 times 2 is 6, divided by 3 is 2, so it'll be 2x, distribute to get -3y equals -15, very good stuff. 2, -3, and 15, A, B, and C. Alright, now let's show you one if you have multiple fractions, because this is what you're saying. Well, of course, you gave me all the easy ones. Alright, let's move our -7, or our 7/2. So we're going to do that by subtracting. That's why I was thinking negative there. -7/2 x plus y equals 1/4. Alright, so one thing we have to do is we know we have to make this positive. So I'm going to multiply by a negative. The next thing I have to do is I have to eliminate all fractions. So here's the deal. What I've told you is focus in on the denominator. Well, if I multiply by 2, does that get rid of the denominator 4? Right now you're thinking, I don't know. Hopefully you're thinking, no. Okay, let me show you. So if I multiply by 2, here's what's going to happen is I'll get rid of this. So I'll get 7x, I'll get -2y, but -2 times 1/4 is only going to give me 2/4, which is 1/2, and I can't have that. So here's what we do. Instead of multiplying by the 2, we're actually going to multiply by, you guessed it, the 4. Okay. So I want to find what the least common multiple is. Okay, just like if you were going to add and subtract fractions. So I'm going to get rid of this multiplication here because that's going to change. All right, and let's finish this up now. So if I multiply negative times a negative is positive, that's good. If I take 4 times 7 is 28, half of that is 14. So now I have 14x minus 4y equals 4 divided by 4 is going to be 1, so -1. A, B, and C. So A is 14, B is -4, and C is -1. Alright, now there was a slide in here that we kind of skipped over because what we want to do is actually do this now. So if I have y equals 3x plus 1, I want you to change that to standard form. Okay, so we want to be able to get that over here. So remember, the first thing we're going to do is subtract 3x. So I got negative 3x plus y equals 1. And then, how do we get rid of that negative? Okay, so multiply by a negative, we should have that taken care of. Other thing we want to do is be able to go back and forth. So if I have this, I want to be able to write it in slope-intercept form. So subtract the 2x. So I have 4y equals negative 2x plus 8. And divide by 4, divide by 4, divide by 4. So y equals reduced negative 1/2 x plus 2. Now we should note here is that this guy is not in standard form yet. Because we have 2, 4, and 8, we'd have to divide it all by 2 to actually put it in standard form. So we're actually dealing with x plus 2y equals 4 will be proper standard form.